Okay, first of all, I can't tell you how glad I am to see so many modular users that is gathered together at one place. And of course it's an honor to be invited here to talk a little about the history of this system from my point of view, and that would be of course be a very technical one, since I'm an engineer and not a musician in the first group. I brought with me, since I heard that some of you brought the system a long time ago. So for those of you who would like the newly printed glass version of the take on there, we'll see those. Brought to bring on this. But be sure that I have a CD-ROM with the software, of course it's the same as more basic people want the last courses. Just let me know. Anyway, something about the background. Clavia was founded in 1983 by Hans Rodelius. And at that time they made digital drum systems for several years. I don't actually know why, because it's more a coincidence that it happened to turn up in the drumming business, because Hans has always been building synthesizers. He's not a drummer. It was just a coincidence that they made his first drum page for someone and they turned out being in market. And during all this time he has been building synthesizers, although none of them ever reached the market until 1995 when the Nordic one was produced. And in August 1996, that what we call the VPS project started, and it stands for the Virtual Patch Synthesizer, which you all know as the modular system. Changed the name later. But I'm not going to give you the company history here. I try to focus on the key persons that were involved in the modular system, and what our goals with this design initially were, and how it came about, and what design decision we were forced to make, and what the consequences of them are. For me personally, I have been with the project from the very day one. You could say it started in 1995, a little bit earlier, in India actually, where me and a good friend of mine was traveling around from town to town for a rather long time. I guess it's one of those journeys you make when you're young. You're trying to figure out what to do next. We had just gotten our degrees in engineering at the Royal Technology Institute in Stockholm. I had been working with physical modeling of a grand piano, modeling a spring and hammer actions. And one of the main subjects that we very often, like I guess other synth nerds, though, was talking about the perfect synthesizer, and that now computers should be fast enough to make a very generic synthesizer. We could connect everything to everything without any restraints and so forth. That's kind of a dream system. We discussed that a lot. And I guess there's nothing unique about this idea. I think all of you have been thinking about this. And then later, I think in December, we returned back to Sweden. I started to work with speech research, speech recognition, and speech synthesis at a small company in Stockholm, where I helped to develop a tool that was exactly such a kind of a program where you connect small building blocks together to each other to produce a signal model that you can load down to a DSP and use for speech research. But of course it was very engineering, more like CAD schematics over this. And later on, this year, a couple of months later, my friend, he answered an ad at Clavia wanted new personnel, and independent of that, I didn't know this at that time. I got to meet Hans through a contact at the Acoustic Musical Institute that I've been working on earlier. And so it happened that we started the very same week at Clavia. The other person was Christopher Richardson, whose main focus was user interface and image processing, and me with my background of digital signal processing for sound. And I can tell you, we were quite astonished that Hans talked about this vision that he wanted to make a modern implementation of a modular system like the old ones. And this was, of course, a dream project. And we started right away. I quit my job after only 8 months. And the three of us started this project. And the first thing we did was to try to evaluate what we were about to build, because we had no idea. There was a very vague picture of what it's going to be. So we started a very few hectic days when we tried to get hold of as many modular systems as possible. We tried to find everyone in Stockholm that actually had one of those working. We traveled around, we tried a Don Buckla system, 200 series I think it was, a Moog system, a Surge, a Roland 800. And we even ordered and bought a newly designed one, the German Defler system. So we bought one of those and played around with it. And during this first day, we tried to narrow down and pinpoint down some essential part, what should be important, the main focus, the constraints for the designs. And I think from my memory now, this is a few of those ones. The most important, because it should be resemble and feel exactly like an old modular system. Clavia is all about retro thing, you know. And we decided that it should be a flat user interface. That was very important. We don't want a window in a window in a window. None of us ever liked those systems. And it should definitely not look like a engineering's diagram or models. More something that musicians are used to see oscillators, pretty much as you see them today in the system. But of course, I have computers over there. And of course, we wanted it to be a modern synth. Although it should have a full MIDI implementation, it should be multi-timbral, and the most important aspect, it was supposed to be a polyphonic synthesizer, not a monophonic one. And another very important thing, that we wanted to be an instrument that you can bring with you. We don't want it to be a system where you compile something and put it in a box. It should be a box, an instrument you could bring. It should work standalone, so you can use it on stage. We were very focused that we wanted this system to reach live situation. We haven't had that success yet with this, but that was one of our main focus. And of course, we wanted the sound quality to be superior, and then I mean compared to like the Nord 2. We tended to spend a lot of the resources in the architecture and the hardware to make good sound quality, rather than have many voices, because the use of such a system would be very, what's the word? Yeah, picky about sound. So we tried our best to have that in mind. One other thing that we wanted, that all signals should be equal, like in old modular systems, could be connected to each other. They should have the same bandwidth, resolution. We had to give up on them, as you know, but more about that later. And the key issue always, as Clavia as a company making drum system, response time is very important. Not only from the keyboard or from a drum, but also in terms of user interface. It should be a real-time system, instant. As soon as you make a connection, it should work, compared to other systems we look like that you often go through a compilation phase or something, download phase or something like that. And then we was figuring how large the hardware should be. We decided that the requirements of one patch, it should be able to hold an average patch synthesizer, and that is like 3 oscillators, a couple of LFOs, a mixer, and that was all. We thought this should be a patch actually, very small compared to what it does today. So we outgrown that one a long time ago. But when we started, it was the aim. One patch should hold 10 or 20 modules. And then we have this big issue that the market was very difficult to predict and see how large it was. So we decided we have to do something very simple and very fast. Actually, we gave the project a maximum 1 year, the three of us working with it. And then we could evolve from there if it's a success. So we said nothing more than that. So we made a very optimistic plan for our development. We said, okay, in 3 months we should have a prototype that we could show to some people running. And then we can give it 3 more months, and then we could go down to probably the largest music fair in the world, the Frankfurt Music Messe, to show it. And it was not meant to show to the public there, rather to clavia contacts, ranging from musicians, press people, distributors, and in general synth freaks that we know, to try the concept, and after that go back home and finish it off within 6 months. So we started. Hans started right away. Hans is the president of the company. He also makes all the hardware design. He started doing the hardware, a prototype. Christopher, who was mainly into user interface, he started to write the editor software, and he chose to use a Delphi, which is a development tool for Windows based on Pascal. But it has a rather large class library with it, so it would give us a very fast development time, although this Delphi class library has a lot of limitations. But we decided that speed was an issue here. Otherwise, we wouldn't have any modular system at all. And I started from the hardware unit, and actually I started with all the algorithms for the main modules. Started to do research, trying to figure out how make oscillators filter sound with the quality that we had settled. And then we worked. I know we worked a lot, I can tell you, day and night. And after 3 months, actually me and Christopher writing the software, we met somewhere in the middle of the communication part between the editor and the software, and we actually had a prototype that could, in some sense, be run. And I actually found an old, don't laugh now. In my archives, I found this BPS early demonstration. This is actually what the program looked like. It was called VPS, the virtual patch synthesizer, and the concept about having a document connecting to 4 slots was already set at that time. It was very basic. We had, is it 6 or 7 modules? You could bring down, oh, it's an oscillator, and as you can see, it's looks a lot like a battery system. And we made a module stand on top of each other. Now you're going to see some ugly cables here. Oh, it has severe limitation. You can only make a connection from inputs and outputs. But it was actually working. And the hardware, it looks something like this at this stage. We have a picture of it. There's a map. Can you see it? Yeah, quite ugly. But it was there, and it was working, and we invited all our distributors, and it was Christmas, so we started in August, and now it was Christmas, and we invited all our distributors to come and look at this system, and they didn't really know what to expect. I think they still thought we were going to show them a new synthesizer, and they were really thrilled about the Norley 1 because they were making money. And they were not particularly overwhelmed at all. half of them didn't understand what it was. The other half were very worried, can we sell this at all? But fortunately for us, Clavia has never given the marketing side that much focus. So we just, they don't know what you're talking about, so we just continued anyway. And after 3 more months, I would say the system looked pretty much the same. We had a designer make the modules look a little bit more nice. I had black knobs and a little bit more colors. And we went down to the Frankfurt Fair, actually, and showed it. And it stood quite clear for us after that time that this system we can't sell to anyone. It wasn't mature, it didn't have the power enough to make, and the patch size that we figure out to make like more a Nord lead architecture is far too small, what other users would like to do. And but fortunately for us that Motorola was announcing a new chip that was the very same and compatible with the one we had chosen, but it ran faster, but we had to wait. So we went home and we continued to develop the system. And not only 6 months, I think it was 9 or 10 more months until the ship arrives, and a lot of other optimistic time planning. And finally, in December 1997, the first modulars left the building. And I don't know, I have the version 1 editor software here too. And I think most of you have seen it. It was a little nice, but today I think this is quite ugly actually. Yeah, you recognize that one. But today I must say I'm quite astonished on how fast we actually decide on a lot of key points to continue the process of evaluation. And I think if I knew that I've been living with this system for 5 years, I have given some of them a second thought, actually. Which brings us to the next part of this lecture, is something about the technical part. And I don't know exactly, I guess some of you knows a lot about computers and some are more musicians, but I tend to keep this on a very high technical level, because if you really want to use the system and you understand how it's built, you will understand why things are possible and why things are not, and why it sometimes acts in your eyes, ears, very strange actually. One of those boring system architectures. Well, I go over in a short. We have the PC hosts the user interface, you all know that, and it's actually connected through a MIDI port. And with all these blocks is actually the hardware, which I'm going to talk most about. The PC actually, it has nothing to do with the sound generation. It's only a graphical user interface, and the only kind of communication going through here is a description. I have one module of this type, and it holds a connection to another module, input number 4, and nothing more than that. And now someone turned knob number 8 in module number 4, and so forth. That's the only communication going on down. On the uplink, there is communication, like all information about signal levels in the LFOs. You have these little LEDs on the modules actually reflecting, sometimes at least, what is happening all the way down in the sound engine. And it goes through MIDI, which is rather slow, so sometimes it lags, that you notice, especially for large patches. Then what we call the host is the main processor, the main computer within one, which actually holds up to 8 computers. And it's a slow Motorola 68K chip running at 20 megahertz. And he's the boss down there. Actually, he takes in all the MIDI communication, he scans all the keyboards, the knobs, all your actions, and divides the works on the different DSP chips. chip. A DSP stands for digital signal processor, and you could say that this is ordinary processor found in any computer with one big difference, that they have used more silicon to make it better for making calculation. It makes it multiply extremely fast. So it's just a matter of, compared to the host processor, how the design of the chip is used. The normal processor is mainly focuses to make conditional evaluation and make branches to do this or that. DSP, he never chooses, he just goes around and calculates a sample or a filter in the loop, so it never branches out of the loop. So that's why there are different chips. But this host processor that makes everything. And the part of this program is something that I don't know if we refer to it as a linker in the manual. But for those of you who knows something about computer programming, there's actually a whole linker implemented there. And what it does is that all the modules are stored within the host source code as in an object file format. And taking the description given from the personal computer, he assembles all the objects files in the right evaluation order. We'll come back to that later. And then the linker starts to resolve all the references and actually generate the native assembler. He generates all the code for that down there. And then he starts to download that code into the DSPs that we refer to as sound engines. And this is the moment when you notice that the synth actually gets silent. Because you could compare it to actually stopping an application in a computer. It stops that and you run a new application, because it's actually building a completely new application, compiling it and everything, rather than have a lot of conditions when you change this. So that they are stopped, all of these bits are stopped and resetted, and you download the new code and it takes about 100 milliseconds. And one other very important task for the host is to actually divide all the voices over these sound engines. As you can see, the host has this is supposed to be the communication parts possible within the hardware. The host can communicate with each DSP that could respond. But the DSPs, on the other hand, is very simple connected in a one-way bus. So the only connections between them, they are in serial, where you have the AD converter in one end, and then there's a 12-channel audio bus routed through the system out to the DAs. They can't speak to each other, they can just produce their samples and add them to the mixer bus. And this is the main reason why the patch limit is as big as it is, because it has to be within one DSP. So the patch limit is how much can you squeeze in one of these chips. And of course we choose this architecture. We could have a very complex one that everyone can speak to each other, but I can tell you that the price of this unit would have been the double, and the developing time for such a system would also have been the double, and we probably would have to stop too early. So we choose to make it very simple for us. And these boxes down here, they're supposed to illustrate the voices, how they can be divided. And I think this is one of the trickiest, most difficult, if you leave out the actual sound algorithms that I'm not supposed to talk about today, is to divide the 4 multi-timbral slots voices over a given number of processors, where you have a given number of audio buses, and making the most out of it, because you have also the common voice that has to be put last in this chain. So actually for all slots you would have 4 chains like these voices, and you want to scramble them over the hardware so you don't have a single chip working at only 20 or 50%. And this is quite difficult to do actually, and this is where most of the time when it silence down, I always say 80% of the time is actually spent in this code just trying to do statistics. How large are each voice, what resources does it use, how many audio outputs is it connected common area, is it routed direct and output, do it need the audio inputs, and trying to the path over these audio buses to the output can be quite a trip for each sample going out. And this is the famous bug where you can put anything in slot D, sometimes. There's a problem with this routing for the last DSP, which in some sense differs. I haven't ping-ponged down yet, but I will as soon as I start to work with it. And for those of you who understands anything what I am saying, should I lower the level or raise it, or is it fine? As you can see, there is a restriction. Actually, the common voice area is a voice of its own. So as you see, it would be possible to have a patch that has double the size. Because you could put the voice in one DSP and the common voice in another DSP. And the reason why we're not letting go of this is the Nord micro modular, which only has one DSP. And we were thinking that we wanted all patches to be compatible with each other, interchangeable, despite which hardware model you choose. But there is a possibility, and there are plans to let go of this with the new versions. And we're going to return to that to discuss things like that. And then you will be able to make the double size if you use the common patch area. But not for the micro, we have to let go of that one. How many of you have, what kind of models do you use? How many key modular users? And how many micro modular users? Yeah, rack. Yeah, and the rack is the rest. And how many run the Macintosh software? The rest. Very interesting. The Macintosh, actually, we don't have any Macintosh programmer at Clavia right now. It's always an issue whether or not we should support it. But in the United States, I think everyone is using Macintosh. I think we're going to continue ours to support that platform. You're free to ask some questions about the architecture before I leave it. You should stay with the PC. I can say we have a very large problem with the Macintosh platform. Sorry, I'm going to drink some water. And that is the new Macintosh operating system, OS X or OS 10. We don't have support for that. Actually, how the software is written for the editor, we use a class library that is actually encapsulating the differences between Windows and Macintosh, so the application is written on top of that. But this class library does today not support a new platform. So on the Macintosh, it tends, since we are most of us, and especially me, being the main responsible for this software, I'm a PC programmer, so it tends to get completed first. It tends to have a little more feature, which it has already in 3.03. There's a lot of things you can't do in the Macintosh version. And I don't know what effects this new operating system will have. There is supposed to be a library that you can compile it with, but they have another layer to use old API calls for Macintosh. But I guess that would mean also that it will run slower on Macintosh, giving all this layering of software. So if you don't have any preferences and you can choose either platform, choose a PC. Yeah, sure.
Why did you decide to use
of course, it's never a choice that you could say, let's skip the analog outputs and have only digital. If you want to have digital outputs, you have to have that as an add-on, of course. Otherwise, we wouldn't sell. And actually, people don't use it as much as you would expect. But it's a cost reason, mainly. I come to that later. Okay, so during this travel, we had to make a lot of decisions, of course, and some of them are, as in all designs, of course, and all decisions you make have consequences, benefits, and negative part sides of it as well. And of course, one of the first decisions we made that is to put the user interface on a personal computer. We were first skissing on having a display, but it would have been too expensive, and why not use the power in a personal computer to make a very nice and neat looking user interface. And we quite early skipped we should not make a car where you put it in a PC, which was also, of course, that would violate the aim of building an instrument. So we decided, okay, we split it in two parts like this, and then of course, how should they communicate? That was one of the main issues. And we was a little bit afraid of using a serial port or a parallel port. One reason is that they are not the same on each platform, and yes, we were discussing Macintosh already at that time, but we said we should wait with it until we see what's happening and make it simple, using Delphi, which was only supporting Windows. And the other reason is the electrical environment on the stage is not the very best. It's so we said if we use a MIDI interface, it is optically decoupled, and it has worked, so it will work. And actually, we thought that was a very good decision. I'm so sorry about it, because at that time we didn't have the thing or the total bandwidth that was going to be used. Actually, we had a system with like 10 modules only transporting a few messages about connections and values. We don't have sequences. We didn't think that we should start to transmit up information about signals, the need to have an oscilloscope or a probe to see what was going on within a patch. It has grown out that picture so much later than when the hardware was already ready and shipping. Too expensive at that time. Today, of course, I think Firewire or USB would have been the natural choice, of course. But 96, I think, even though I know what I know today, given the constraints and all how it works, then I would still make the same decision. But I didn't know that a personal computer, then Windows can't keep with MIDI, that it was so bad implemented in Windows. We have had so huge problems with MIDI interfaces and badly written device drivers that we could have developed a custom port of our own and actually put in each box to each other, and we would have still gone plus on that. But there's so much trouble with MIDI, and we can talk about that later with overflowing buffers. But I can tell you it's not difficult to take 800 megahertz Pentium, sending a MIDI stream with 31 kilohertz and making it totally crash by just sending MIDI, because it can't deal with this large amount of data actually. Because it gets too many interrupts, and MIDI interfaces have very small buffers, and they are never written to expect that it will get an overflow. And well, I guess a lot of you have had problems until you have found a solution with a MIDI interface that works with your computer. You could compare it like burning a CD-ROM disk. You have to turn off your screensaver and everything, otherwise you get a buffer overrun. It's exactly the same with MIDI in a Windows PC. I spoke to a person at Microsoft last week about this. Said he was going to look into it with this new DirectX music, and I told him that DirectX is using the MME DLL system. Andre, it is, he said, and then I left. Okay, one other crucial design was that to use very little memory for the sound algorithm. We say, let's make this an algorithmic system. We don't going to use sampling, it's not going to be an effects rack. So we try to use the built-in memory within a chip. There are no external random access memory for the DSPs, and this is today one of the things that I like the most, because this means a lot of things has to go, modules like delays, reverbs, pitch tracking, pitch shifting, band echo simulations. It's not possible to do because there's only 4 kiloword of memory within each chip. So all the modules is calculated. There are never any samples or any tables used. Everything is done with algorithms, calculated like formulas. Media port has a PC connection. I think we talked enough about that. And then is one main issue: how to deal with a feedback connection in a digital system. However, we want it to be an analog system, it will never be, because its sampling and time is discrete. And that will be a problem when you connect things back in a loop, because then you have a time delay. You have to evaluate one sample before you can see it in the next iteration. And this affects algorithms a lot, giving stability. And of course, if you make a system just connecting its own sound signal, but when you make very advanced algorithms, and I know some of you do, when you actually rely on a feedback connection, you don't know exactly what kind of delays you get and where. And you could say you could have 3 strategies to do this. The simple one is we don't care. We just randomly get the delays that we get, and most people won't notice because they make sounds sources through filters to outputs, and that's it. The second approach would be to have a parser actually parse the whole connection scheme, and having a row to insert the minimum number of delays only at the positions needed. This would mean that you actually have to recompile when you make a new connection. If you alter or if you create a feedback loop, you have to reorganize the whole code and you have to recompile. And this would violate with one of our main criteria, that this should be a system working in real time. You should be able to make connection, change the parameters. So we skip that at that time, but it is still a very hot issue at Clavia, how we should do with this. And the third solution would be to introduce a delay at every module. Just calculate all the results in one parameter frame and don't make it public until the next iteration. That would mean you will never have any timing problem with the sequencers, and everything would be very synchronous and work very well. But you, on the other hand, you will not be able to make those very complicated algorithms with feedback, because they would rely on having one feedback. If you connect 5 modules in the chain, you will have 5 feedbacks. So then you will be back on at start again, because then everything will be synchronous and fine, but you can't do it anyway. So we choose the first one. And you can, if you know how the system works, when it places the calculation order, you can work it around. And it's very simple. It places them in the order you drop them on the screen. And if you delete the module, you get a hole at that position, and when you place a new module, it finds the first hole and put it there. That's the algorithm. So you can always start from scratch, just putting crucial change in the order, and you will have it to work. And it goes for all very, very complicated sequential patches when you have feedbacks with clock dividers, etc. and so forth. Most of the clock logic signals has a protection for this, because I've implemented at these inputs actually have this extra delay at some clock inputs, at some crucial synchronization signals, so you don't have to think about it unless you reach the depth of 3 layers in feedback. And I think I know only 2 people that does that, and it's Rob and it's Wieland Samolaki. I've never seen anyone else, so I don't think it would be a problem. Sam was the aim about signal. How should we treat signal? And I can tell you, a lot of those old signals, they seem like they were randomly designed, because the scaling of different inputs, the scaling for pitch or different modules, and modules that were built a couple of years after the initial design, there was a lot of differences. So we said we should focus on actually put a standard, a really good standard for all the attenuators, for inputs, for all modules, for the pitch resolution, for how you can convert a signal from a level to a pitch. It should work, you should be able to change models very easily, so everything is normalized and it has a range that you don't compare as like the generator system. You sometimes have to put in a multiplication factor to .13 to make it correspond to something you can understand. I think that's one of the strengths of this system, because you can, even though you don't know anything about signal levels, you can connect things and it still works quite okay without you giving. If the system is very well designed, it's transparent, you don't think about these problems, you just connect an LFO, and it has the right polarity, it is shifted the correct way. So we put a lot of time into actually trying to get this right, and also for the definition of different types of signals, because we wanted everything to be audio bandwidth, but due to performance we had to let go of that, and we invented that we should have two levels. The audio bandwidth, which is 96 kilohertz, and then the control signal bandwidth, which is only 1/4 of that. And this, of course, creates a lot of problems, because as soon as you make a new module, it all has these questions: what inputs should be full bandwidth, what can be just controller modulatable, and so forth. And I don't like it, but it's until the DSP chips are 10 times faster, I think this is the way the system's going to look. You have to do these compromises, and I would say it works fairly enough. Hopefully it's very clear when you read the manual. We have a large chapter about these different signal types. Most people I've heard skip that chapter. And then we have electrical signal behavior. If it was supposed to be a model implementation mimicking in a true patch synthesizer, there's nothing stopping you from connecting several outputs together. You can just connect them and actually make things. The Don Buckler system, for example, you can do mixing that way, it's no problem. And also you have pull-up resistance at the inputs. What is the definition for a signal when you have an open connection, where it's actually not grounded or connected everywhere? And the system has pull-up resistors, so that works, but it doesn't work iterating backwards in a chain. If you have an on-off switch and you open a connection, it's not able to comprehend that and making the correct signal. And regarding just tying together several outputs, we said you have to use a mixer. Other MNO systems, anyway, you don't know exactly, because how you're loading the system and what the exact result is. Of course, some strange things might happen. We said there will be enough of sounds, just having this restriction that an input should go to an output. It's not that strange. And of course, there always, as later there, also I just took a few of the questions that you often get. So I have a very long list, of course. One thing that people very often ask is, why is there so many modular variations? Like in oscillator section we have 12 oscillators, one for each waveform, and then we have one containing all of them with a button, and everything about this has to do with performance. If you want to put in the code where you can choose and select in real time where the system is running between different waveforms, of course, you have to put some code in that decision and taking away resources from the final result. Yes, they're copied. And also we invented this master-slave concept for two reasons. One is that it's very convenient to work that way if you have relationships between oscillators, if you do an FM patch, of course. And the other main big thing is actually, if you want an LFO to modulate, you have an exponential module at the first input on the pitch modulator. You have to do a transformation to pitch, and that involves a mathematical operation that is not that cheap. And why carry the burden to have that in every oscillator when you can actually connect them from the first one and then use linear output. So the master-slave input is actually a signal that is direct proportional to frequency. And you can actually use it to get very large range to modulate a linear modulation of signals. But that's also, as every time, let's do a new oscillator. It should be a master oscillator, should be a slave oscillator, and should it be both? And this other problem, should it run in background, should it run on full bandwidth speed? Then personally I don't like this. It doesn't make the system transparent when you easily end up with 400 modules if we keep on building like this. And for you that has been with us from the start, that will probably not a problem, but for a new user that could be quite confusing. So that is one of the main focus now when I start again. How can we get around this problem in a transparent way? And we're going to talk later about that again. The same thing with modulatable inputs, performance. Of course, it's a patch synthesizer, so all parameters should have a modulatory inputs. And I aim to work the system towards that direction. But we were so afraid about performance. We wanted this to be a polyphonic instrument that normal musicians on stage could play. So we dropped a lot of those. And today, you can put them in. That would mean that a lot of your old patches wouldn't fit again because they would be larger. But on the other hand, most users don't use this system as a polyphonic instrument. So this is a discussion, and this is one of the key issues that I would like your feedback if you, in what direction. We could stop this lecture later. So is this sequencers? No one understands the sequencers. and the evaluation of them is very clear, of course. But they started that, let's have a sequencer. Yeah, great. How does a sequencer work in a patch synthesizer? Well, it has a clock input and you have different levels. That's nothing strange. Everyone understands that. You can clock out different signal levels. So we made that. Very simple. Okay, I want a longer sequence. Let's connect them together. And then you have this restraint. It's a patch synthesizer. All modules should be independent of each other, and all information between them is actually traveled in an analog, so to speak, signal while you make a connection. And there, when we fail, because we stick to this old vision of the system, so we started to invent, you could have a reset signal and you could connect them in parallel and have different synchronous, and no one understands it, to make a complicated thing. But it fulfills all the requirements for an analog system with independent boxes. Today I think more in the terms, why not make a very modern system? You could have like an Ethernet path. Why should it be analog signals only? You could have a digital signal you connect that actually addresses all the different sequencers and they just work together. You set them in a base module, very simple, range, how many brushes in parallel and so forth. Other ideas is of course to have freely resizable models. Why just drag the model, make it twice as wide? That would be very simple, and it doesn't have to be a module synthesizer in that sense anymore. We could step on to a very more modern system where you can actually have a mixer. How many inputs do you want? You don't have to choose between 5 or 6 or 8 modules. You can just drag side and change the size of it and have as many inputs as you like. And then you don't have to have all these inputs. So these are some of the few ideas that we have right now. Or you could also put sequences together. Normally, how do you put them as the way you want them to work? Next to each other and in parallel under each other. So why not just have connections have a meaning? Position on the screen can in a modern patch synthesizer also have a meaning. You put them together, you could select all of them and just say join, and they should run. And you don't have to make one single connection. That would be much faster to work. But when we designed this, it was so much a patch synthesizer. I'm not that afraid anymore to step out of some of these that is actually not very good about it. To mix a very modern approach with the old philosophy, and just making a very good tool to make music. That's what it's all about. the sound that change always. There are two main things for that. One, which is a small problem, which is probably not the one you hear. That is when you drop a new module, you can change the evaluation of order, and you can have a feedback path which actually have a different number of delays, and then you actually have a completely new algorithm in some sense. It will sound a little bit different, but what people most often hear is the phase relation between oscillators. You don't have control about that in analog systems. All the phases for all oscillators, they are random. You never know what they're going to be. And you drop a new system, you go through all this process, you tear down the code, you stop the evaluation, you assemble a new code, you download it down to the DSPs again, and you start, and it won't have the same phases as you just had. And it will sound slightly different from most sound, but if you make an FM patch or FM connection, it will sound totally different, because the phase in FM is so crucial. And of course you could say that you will have more control over the FM part, but I kind of like it. It's a system exactly like the analog. The same thing happens between voices. All voices will have different phasing between oscillators, and they will sound a little bit different. That's one of the great things about a system like this. It's not a sampling system where everything is a snapshot of what it just was. Things happen. I personally like that. You might agree or disagree. From the beginning in the version 1, that was not the case. I think I remade it from the version 2. That people, if you reload a patch, actually the random seed used for this is resetted within a patch. So so it will be random as long as you not change it, but it will be random in the very same way. So yeah, yeah, and then you want to save it that way. Then you have to synchronize your oscillators and create a phase, and that's a lacking support for that. It's rather complicated. That's an issue actually, to give some thought. So I leave you here now. So the future, I know as little of the future as you know. No, that's not true. Actually, what is happening at Clavia is when we released the editor version 3.03, that was the last thing anyone has done at this system. No one. And actually, the cash flow was rather low at that moment in Clavia, and the decision was no one writes one single line of code on this system. Let's make some volume products. So I have been spending 1.5 years making the Norleads 3 together with Hans. We made that unit and it's just completed. And it seems like we can make some money on it, so we can continue to do what we like most. That is the modular system, because everyone at Clavia wants to do nothing else than to work with this system, because this is our favorite. Of course we like our drum system. No one likes the drums. It's why we should make drum. Yeah, sure, we should. And of course, we're very fond about the Norlead series as well. It's a completely different product. And actually, I brought the Norlead 3 with me, so people can try it out and listen to it. And Björn, today or tomorrow, I think Rob has to decide it's here to use for everyone who wants to try it. Or if you, I can talk about it tomorrow if people like that. You can see. I brought it anyway. And Björn is about finishing up the electro software as it looks right now. Me, Björn and Hans is going to start work for 1 year on another system. And we're going to start with making a very long-awaited bug fix version. I think we start within 3 or 4 weeks, and then just to sit down with all the reports, trying to fix them and make a new version with a couple of new models. We have a couple of new models already written, actually, and make a release quite fast, and then sit down with the more interesting issues, how it should change, what direction we should take with the system. There calls a person every day that want to use this system in all different sort of ways. We have DJs, this is actually using this as a club, and they want more effects. They run drum grooves through the compressors, and they have their kind of requirements. There are actually guitar player and bass players that uses this as an effect rack, very advanced, and they want a micro modular, more like a stomp box with large buttons so you can turn things on and off on the floor. And of course there's a lot of people that make use it as synthesizers, which was our first aim. But there are more ideas and there are more ways to go than we have resources to do, so we have to just light a flashlight out in the dark and hit in one direction, and this is where you all come in now. This is a great opportunity to get feedback from very advanced users, I guess, coming from all the world. And I picked from the list, which is very long, some of the ideas and discussions that have been circulating at Clavia, and this does not mean that any one of these is going to show up. It's just a starting point for this discussion that should resolve problems that people have been complaining about. And the first one I already mentioned, that is let go of the common area restraints. That would be very easy. It would take me 3 minutes to remove that constant, and it should work. What we are afraid of is all those micro-modular users that certainly they find themselves in a position that every second patch they can run. How does people feel about that? And of course we have to move on forward. Sometime we have to do that. We can't keep the backward compatibility forever. Then we will be stuck pretty much as it is today at some point. But maybe that point is now to actually making use of the more power that are in the large models that has expansion boards. One other problem with this would be that we wanted this to be a multi-timbal system when you have 4 slots. That's why it's designed around 4 DSPs, that you're always guaranteed to have a monophonic patch synthesizer in each slot. If we double this, you can find a situation where when you use slot A and B and C and D can't get any voices. If this wouldn't be a problem if you buy the expansion board, because then you actually have exactly 8 DSPs and this requirement would be fulfilled. So on the other hand, you can use it with the double capacity.
If you did do this, would it be possible to actually find a different patch name on PCH with
That would be one way to go, to at least getting a sign every time. Sorry.
You're getting a situation where you know there are forbidden patches rather than...
Exactly, and you can download on our website. You have the libraries for both parts, so that could be one way to resolve it. Too much, that wouldn't be possible, no. But you could rather make a new micro that actually had 2 DSPs in it, but that doesn't have the old users anyway. Of course, if you decide to make new hardware, anything is possible. Sorry, it's not possible. You mean for buying the new hardware? Okay. Yeah. Send in the old one and we replace it for you. Yeah, why not? Then we have been discussing about this, as I talked about, why not have variable module size instead of have many versions of the module. A much more simple approach would have to actually have a more intelligent replace function. You could have like a drop-down list within a module where the different kind of modules you actually can replace this module with appears, and then you know this would require recompilation compared to making a connection for a mixer. All the mixer sizes would appear. For the slave oscillators, all slave oscillators would appear, and so forth. Today, when you decide to swap a module, delete, you connect everything. You didn't have to do that. You just replace it, and it can be very intelligent to put things at the correct place. Another idea we have is to implement, we actually had this in version 1, it disappeared along the way, user templates. And the main idea today, how to do this, would be to have an extra position in the toolbar, which has user with buttons, and you just make a selection, and you drag-drop this on top of the button, and then when you press that button and drag down, you don't drag a single module, you drag this whole selection down.
It's so useful for building.
Yeah. I think all of us, we tried to have in the system 1 a start patch that was defined by us, but I find that all of us have our favorite starting points. I always do this and have my style. I want modules on the left side and that on the right side, left, right. Other thing is people want some kind of search tool within a probe or oscilloscope you could connect, just point out what kind of signal they have in this point right now. And there we have one big problem, it's called MIDI. Because the sound is down here and the user interface is up there, and you have to go through the DSP, through the slow host, through the MIDI interface, through Microsoft and up. But something could be done. Yeah. So that is very high up on our list. Also, user-defined labels on inputs. What I mean by that is if you try to build a more general architecture, building a synthesizer, you often have a selector when you select destination, like the Nord is made up. That's actually very difficult to do within the modular system. It's more aimed for building this is this sound, this is this sound. But if you want to build a synthesizer and have your own selectors, and then you want to use it without the editor, you can't use it actually. But if you could put a label on the selector 1, you could say this is LFO destination, or actually given names that could pop on the display, on the knob filter, and so forth. That would be a help to build such kind of patches. Sending MIDI from within the patch, it's a hot issue. I see only one problem with this. That is the MIDI overflow. It would be very easy to connect in a MIDI. As soon as you connect this to a sequencer program, it will echo these events back, unless you put the sequence in another mode, or if you do very advanced patches when it's slot A, sending MIDI to slot B, sending MIDI to slot A, sending MIDI back to slot A. Of course you want to do that. And if you have one MIDI event that is generating 2 MIDI events each turn, sooner or later the system is going to stall because it can't cope with it. You're actually generating from each event more events. And
it's a normal problem.
yeah, it's probably a normal problem. My experience throughout this year is that people, the kind of problem that I think people's going on has nothing to do with the problem that people have. You do very complicated things, no one asks about it, and then people ask thousands of questions what a global MIDI channel is, and so forth. And it's going to be a lot of users. I don't think anyone in this room is going to have a problem with it and can see what it would mean to put that power in the machine. It also means you have to be more careful. And it's getting a more complicated system. And a lot of users don't use the system in that way. And I would like to find a way where it could be very advanced for very advanced users, actually having more of the MIDI implementation going down in, but why don't send all MIDI in there, all MIDI channels, all events?
Would it be possible to have advanced configuration options? In other words, advanced configuration, if you choose this, you could run into problems.
It's of course it's possible, but it's not very clavia. There's one thing that we always try to fulfill that is as little modes as possible. We don't want that. Sooner or later you're going to find a system based on 100 of menus, like I would say every other synthesizer in this world. I don't like those synthesizers. That's why I work to make the Nordic 3, where everything you can do is visible on the screen or on the panel, and that goes for this instrument as well. And you could compare this system to other very advanced system, Creamware, the Klima. You can do a lot of things, but you can't do it as fast as with this system, because you can do it only one way. But and that's the key point with the whole design. We choose to remove a lot of possibilities, and the most time we spend is discussions like that. Should we have this feature? And if you give people just one finger, they want to hold a hand all the time. So it's better to not have anything to do with this at all, and no one would complain. If I do a little thing, people want more, and sooner or later we would have a system that no one likes. You think you like it very early. I would like that. You want more. I bought the system, you want that, and you really say you're not using this one anymore to do your music. You use another system, but you didn't understand what happened, and that's one of my greatest fears. We try to keep it as simple, although it is a very complex system, and that's a delicate task. And so forth, something I would have done differently, and something I think works very well.
But maybe be helpful for a stage where if you only have a big micromodular is to print out a list of patches.
Yeah.
Otherwise you need to write down all the numbers.
That would be a very simple thing.
Yes.
Yeah. That's a very good one, actually. But I know I promised someone to make a MIDI module, so it's on this list. That means that I haven't rejected it totally. I mentioned, moving larger parts of the allocator. The main issue when we started, let's remove this polyphonic thing out of the patch. It would give an extra complexity and abstraction layer on the system. You have to understand what is actually happening when you have a polyphony within a patch. So we decided to have like a normal allocator, note allocator, when you play a keyboard outside, and then you just focus on your single patch. Of course, you can make, if you don't use a VCA, you can have 10 voices sounding at the same time, and if you're a little clever, you can actually connect knobs that goes to each. Although they are mixed together all the time, you can have knobs going to voice 1 and voice 9 in the very same, and the very advanced layering. It's unfortunate that Vilan isn't here. He's reading somewhere. Expert on that kind of usage. But I think we have to move more of that down, doing glides and first note, last note priorities, and building modules so you can easily either use the built-in for everyone who just want to make a synth sound, use that, or you could bypass that and actually connect a whole MIDI implementation down there. That would be one direction to go. Locking slots during linking. That means, sorry? I explained what it means to all who doesn't understand it. It would mean actually that you could decide that C and D, you lock the resources pretty much the same way that you lock the number of voices today. That's a decision you make. You could also say that you lock the resources for a couple of slots. The slot C is using these two DSPs, and they are not to be recompiled. Now you could change the sound in the other one without affecting. You have a continuous sound all the time. Sorry?